Hello, this video is on a more complicated type of word problem than we've done before, called a wind or, in other cases, water current problems. Whether it's a wind problem or a water current problem, it's really the same type of problem, just applied to a different situation. So first of all, in both problems, we're going to be dealing with the relationship between distance, rate, and time. And this is something that you've talked about for several years in math class, the relationship between distance, rate, and time. And so by now everybody knows that rate times time equals distance, or the other way around, or you can put it in terms of you can solve for r or solve for t. Okay, all of this stemming from this fact that if you take the speed of an object multiplied by the amount of time going at that speed, you will get the distance traveled by that object. Okay, so in the problems I'm going to show you today, the object we're going to be dealing with are flying objects, like airplanes, or objects moving in water, like boats. Okay, now when we have an object flying, there is something working against the speed of that object, and we're just going to call that wind. So if there were no wind, an airplane, for example, would travel at some kind of speed based on how powerful its engine is. Alright, so there's my airplane. But if there is a wind working against, going at the head of the plane, this is called a headwind, that's going to slow the plane down. So if I call, well, I'll use an R since we're talking about rate. If the plane, without any help or anything working against it, has its own speed of capital R, miles per hour, when this wind, which has its own speed of small r, miles per hour, hits this thing going at capital R, miles per hour, overall, the speed of the plane will decrease, right? In fact, we're going to use this formula. When the wind has lowercase r speed and the object has uppercase r speed, the overall speed becomes r minus r, miles per hour. By the same token, if that same plane has a tailwind, so the wind is helping the plane go faster, and if that tailwind is, I call y, then the overall speed will be the speed of that plane without any help plus the wind speed. So in this case, the speed of the plane will be r plus y overall. Okay? In real life, in the science of physics, it's not that simple. You don't just take the speed of the plane and subtract the speed of the wind and get the overall speed. There are other factors involved. And same for r plus y. It's not that simple, but at our level, it is going to be that simple. And then if you have a boat traveling in the water, and let's say the boat has an engine, okay? That engine has its own power, right? So if the water were providing no resistance, that boat would go at a certain speed based on that engine, based on the motor. But as we know, water current does offer resistance. So while the boat has its own speed in still water, the current may be going against the boat, or it may be helping the boat. So if the rate of the boat in still water is capital R, and I'll be smarter here, I'll use X for this current and Y for this current. So just imagine there are two situations, one when the boat is going downstream, one when the boat is going upstream. So when it's going upstream, then the current is making the boat go slower, so the overall rate would be R minus Y. If the boat is going downstream, then that current with rate X will help it go faster, so the overall rate will be R plus X. Okay, so keep those two situations in mind. Okay, here's our first example. So these word problems are kind of wordy, so I'm just going to write down just the bare minimum information you need. So we have a plane, and if there's a tailwind, that means the wind is helping the plane go faster. The plane goes 70 to 120 kilometers in 2 hours. With a headwind, that means the wind is slowing the plane down. The plane goes the same distance, that's 720 kilometers, same distance, in 3 hours. Find the wind speed and the airspeed of the plane. Now, in problems where it says airspeed of a plane, they mean the speed of the plane without any help or hurt from the wind. Okay? So in still air, that just means the same thing as still air, when the air is not moving. Okay, so to set this problem up, we're going to go to our basic rate times time equals distance formula. Except I'm going to write it as time times rate. Times time rate. I just like doing it that way. Now, we're going to have two equations. Why is that? Because we have two situations. The plane going against the wind and the plane going with the wind. So in my first equation, I'll do the tailwind equation. Plane going with the wind. So with the wind, the time it takes for the plane to go 720 kilometers is 2 hours. The rate that it goes during those 2 hours, I will fill in later. The distance that it travels in 2 hours, 720 kilometers. Second equation. This is going to be the headwind equation. It takes 3 hours for that plane to go 720 kilometers. Now let's take care of that rate. So now I'm doing this part. Now the rate is not going to be some single number, because since this is the tailwind equation, that means I have to take the airspeed of the plane and add to it the wind speed, both of which I don't know. So I have to use variables for both. So I'm going to call the airspeed of the plane x and the airspeed or the wind speed y. Now in the headwind equation, we have the airspeed of the plane again, but this time the wind is the plane is going against the wind, so the overall rate is x minus y. Okay, So this is going to be the overall rate, which is composed of, in the tailwind equation, the sum of the airspeed of the plane and the wind speed. In the headwind equation, the overall speed is the difference between the airspeed of the plane and the wind speed. Now, in both of these equations, I can use distributive property. And now I can use elimination, I can use substitution, I can use determinants to solve this. Now I'm not going to show the solving now because I don't want to make the video too long, but you've seen this before. Most of you I know would probably use elimination, right? To get rid of the x or y. When you solve for x, that's going to be the airspeed of the plane, and when you solve for y, that's going to be the speed of the wind. Okay, now I'm going to do one boat problem. Okay, so the boat problem. We have a boat, and downstream, that means with the current, the boat goes 4 kilometers in 20 minutes. Upstream, return trip. That's just a fancy name for the same distance. Takes 24 minutes. Find the current speed and the speed of the boat. Okay, first, the downstream equation. That's when the current is helping the boat go faster. So in the downstream equation, we have the time again, 20 minutes, the speed of the boat, plus the current, which is helping, and it goes 4 kilometers. Now upstream, takes 24 minutes, speed of the boat minus speed of the current, same distance, 4 kilometers. Now, before I actually do the calculation here, I wanted to point your attention to the units of the values given in the problem. We have 4 kilometers, 20 minutes, and 24 minutes. If I solve for x and y here without changing any of these numbers, I'm going to get a number, a speed, in kilometers per minute, which is fine, but usually we don't express speed or velocity in kilometers per minute. We normally use kilometers per hour, or if we're doing miles, miles per hour. So I'm going to change the 20 and the 24, since they're in minutes, and I want to express my answer in hours. I'm going to change those into hours. So 20 minutes is 1/3 of an hour, so I'm going to change that to 1/3. 24 minutes is, do a little quick math here. Okay, 2/5 of an hour. Okay, now this is in kilometers, this is in hours, so my answer is going to be in kilometers per hour when I'm done. Okay, now I'm actually going to do the solving for this one because there's a little trick I want to show you. I am not going to use distributive property here. Instead, because I have fractions, I'm going to multiply this entire equation by 3 and this entire equation by 5. So multiply this by 3. My new equation is x plus y equals 12. Multiply this one by 5. My new equation, 2 times x minus y equals 20. Now I will distribute my 2 here and multiply this equation by 2, put it under here, and do my my elimination. I'll go ahead and finish this because I'm almost done anyway. X is 11, so that's the speed of the boat, which makes y 1. Yes, y is 1. That is the speed of the water, the current, both in kilometers per hour. Okay, there's your introduction to wind and water current problems. See you next time.